All right, hello there. So today in this video, I'll be going over the basics of Unit 1 in our statistics book. And so I'll be starting from the first lesson, which is on page 3. And yeah, whenever there's a vocab word, you can follow along, write it down, and I'll just go ahead and get started. So statistics is the science of collecting, organizing, summarizing, and analyzing information. Um, a lot of times when you see statistics in the news or in research, well, less so in research, but usually in the news, it is done with the first three are done: collecting, organizing, and summarizing. In research papers, you'll be seeing the analyzing part a lot more. But usually, what the general public see is usually the summarizing part. Um, and so this is the definition of statistics. Uh, there also needs to be an extra part here that I forgot: to draw conclusions or answer questions. And so statistics needs to serve a purpose. Data that is collected without a purpose is it's still data, but we can't really consider it statistics. Okay. Uh, so some keywords you need to know from this chapter are population, sample, parameter, and statistics. Some of these words you've probably heard before in some capacity, but I will go over the definitions as they relate to this class. So the population is the set of all individuals that is being studied. The set of all individuals being studied. Um, and so, for example, we might talk about the population of an entire country, or the population of an entire school, or the population of an ethnic group, or the whole population of people who are this tall. So it's a set of every single person that fits that category. Um, Oftentimes, it is not feasible to get research on the whole population. Uh, Usually because the population is too large or there's just not enough resources to get everyone. And in that case, we take a sample, which is a selected subset of the population being studied. So this is just the subset. How we're going to select our sample, we're going to look at in about 7 slides. But the sample is just a smaller group. Um, Samples can be divided into good samples and bad samples, depending on how well they represent the whole population. For example, if I wanted to study the population of Cricks, which means everyone who is in Cricks, a good sample might take a good sample of the students might be the student council, right? Where there is a representative from every grade. A bad sample might be me taking just the 12th graders, uh, and that would not represent the structure of the whole school, right? Um, and in this case, I am kind of ignoring the fact that there are also teachers, but in general, that's kind of how it works. Next two is parameter and statistics. Parameter and statistics are measurements. These are numbers that you will see. Um, the difference between a parameter and a statistics is whether they relate to the population or the sample. A parameter is a measurement that a measurement of the whole population. For example, the a parameter might be the average age of every single person in the school, which we could do. We do have a list of students and a list of teachers. We could figure out every single person's birthday, and then add it all up, divide it by the number of people there. It is possible. Um, but if I'm trying to get the parameter, the average age of every single person in Chiang Rai, that is much harder, right? Usually a parameter is something that we do not know, but that we are trying to find out. And we can find that out by using a statistic, which is a measurement of a sample. So we use a statistics to guess at a parameter, right? So for example, if let's say I take 1,000 random people from Chiang Rai and I get the average age is 28. I might be able to guess that the average age of every single person of Chiang Rai then is around 28. Um, Again, that's not very statistically sound, but that's an example that I can give, right? Okay, so we'll move on then to types of data. So that was the end of unit 1. Actually, before I do that, let's do some examples. So in your book, I am flipping the page and I am now on page 4. And so on the bottom of page 4, there are questions about identifying the population and sample. For example, question 3, April 2nd, 2015, 6,000 adults, it should be 6,000, not 600s, US adults were asked if they think man-made climate change is a problem that deserves immediate action. 2,165 of the adults said yes. And so here the population that is being studied is actually every single US adult, right? Every single one. It's not really feasible to ask every single US adult this question. And so the sample that they selected was 6,000, right? They got 6,000 people. And so the population is all US adults, and my sample is 6,000 US adults. I'm moving ahead to the next page. Question 7 says, a survey in 2014 in a sample of statisticians reported that the average salary for a statistician is 90,350. So because this one specifically says that it is a sample, this number 90,350 is gotten from a sample. And so this is a statistic. On the other hand, question 8, starting salaries for all of the Olympia teachers increased by 1.8% from the previous year. This number 1.8% is describing every single teacher at Olympia. And so this would be a parameter. All right, I'm going to move on now to the data classification. And so now we're on page 7. Okay. So data comes in two big types, right? When we're collecting data, they fall into these two categories: quantitative data and qualitative data. Now, quantitative data, the root word here is quantity, right? This is data that is numerical and that you can do addition and subtraction on. This is data with meaningful, if I can type, meaningful numerical value. Now, this is important, the meaningful numerical value, because just because it's a number does not mean it is quantitative. I'm going to just define qualitative first, and that is without a meaningful numerical value. So some examples would be, for example, phone numbers, right? Phone numbers are numbers, but the numbers don't really have any meaningful numerical value, right? I can't add or subtract phone numbers to get a result that would mean something. Same thing with, for example, sports jerseys. Those usually have numbers in the back. I can't really subtract two numbered jerseys from each other to get a meaningful value. So those are qualitative. Qualitative data can also be words. For example, colors, red, blue, green, those are qualitative. I can't do math on those. Some examples of quantitative data might be the number of years, right? Years since some number, or just the calendar year. I can subtract 2008 from 2012, and I can get that, oh, that is 6 years apart. That number has a meaningful value. I can do numbers of the number of sodas sold at the snack shop. Again, I can add, subtract that, and get a meaningful result, right? It can be temperature. Again, I can add or subtract. And so those two are the basic overarching categories of data. Okay, and so now we're going to be looking at levels of measurement. And so there are 4 levels of measurement grouped underneath quantitative and qualitative, and I just realized that I swapped these. So sorry about this. Let me swap these real quick. Okay. So I swapped the positions of these. So qualitative data, again, data that has no numerical value, can be further categorized into nominal and ordinal. Data that is nominal are data that can be put into categories but cannot be ranked. Cannot be ranked. And what I mean by cannot be ranked is that there is no mathematical way or numerical way to rank these data. For example, colors, right? I cannot, it's not really possible to rank color numerically. Like, I can't say that red is mathematically better than blue, right? And so that is gonna be a nominal level of measurement. Next up is ordinal. Ordinal can be put into categories, can be ranked. Data that can be put into categories, ranked. Let me just spread this out a little more. But the difference between ranks is insignificant. This is probably the hardest one to make sense of. Sorry. Ordinal data can be categorized and ranked, but the difference between the ranks is insignificant. And what I mean by that is, for example, the top 5 grossing movies, right? Let's say look up the top 5 movies that have sold the highest or had the highest profit, and I just rank them by name, right? 1, 2, 3, 4, 5. Now mathematically, there is a ranking there, right? The first one got more money than the second one. The second one got more money than the third one. The third one got more money than the fourth one, and so on. But the difference here is that the difference between them is not consistent, I guess is a word you can use there. The difference between the top grossing movie and the second might be different than the second to the third, right? And so there's no constant difference there. If I take the 5 fastest runners at Crix, the difference between first to second and second to third and third to fourth and fourth to fifth, the difference between those are probably not going to be consistent, right? It's not going to be the same difference every single time. And so those data we will put into the ordinal category, where the differences is not consistent, and but we can still rank them as fastest to slowest, or biggest to smallest. Well, biggest to smallest, usually the difference is consistent. But yeah, fastest to slowest, or things like that, right? All right, next up, we move on to the quantitative levels of measurement, to the interval level. So interval levels, let me just move this here. So again, categories, it's in categories, it can be ranked. The difference between ranks is meaningful, but there is no inherent zero. So we're gonna have to explain inherent zero a little bit, and there is a space for the for that definition down there. And so I will just put a post-it note. Inherent zero. When a zero means the absence of the variable. An inherent zero is when a zero means that there is none, essentially. I'm gonna explain ratio first, because that way I can compare the two a little bit better. So the difference between interval and ratio is simply that there is an inherent zero, and there is an inherent zero. So I'll give some examples, and this way it might make a little bit more sense. So nominal, as we discussed before, these can be things like color, or shapes, or just names of cities, right? These are data that we can't really rank them, and so they would just be nominal, right? Ordinal have some sort of rankings. For example, top grossing movies, top grossing movies, fast, most successful NFL teams, or, and this is gonna feel a little weird, or I can say most populous cities. Now, if I just want the names of cities, and it has nothing to do with how much population is in there, that data will be nominal, right? However, if I want the cities and how many people they have in there as like a data point, it would become ordinal, because now I can rank them, right? I can rank which city has the most people, which city has the second most people. But the difference between the most populous, second most populous, third most populous are probably not going to be consistent, right? And so that would just be ordinal. Now, interval. Interval levels of measurements do not have an inherent zero, which means that at zero, it doesn't mean that there is none, right? The best example of this is temperature. Is temperature in Fahrenheit or Celsius? Because when we're at 0 Fahrenheit or 0 Celsius, that doesn't mean that there's no heat at all, right? You can still go into the negatives. Another example of this would be calendar years. Because again, the year 0 AD doesn't mean that there's no time, right? It doesn't mean that it's the beginning of time. And so those would be considered interval levels of measurement. Another And for ratio, that means that 0 means that there is none, right? For example, temperature in Kelvin would be ratio, because Kelvin cannot go to the negatives, right? 0 is where you start counting for Kelvin. Height and weight are also ratio. 0 centimeter height means that you have no height, right? And 0 kilograms weight means you have no weight. And it doesn't make sense if we go into the negatives, right? And so these are some examples of ratio level of measurement. And so there are some examples that you can do here. I'm going to skip them for now just to save us some time. But you can try doing the homework on page 16, 15, 16, 17, and compare with your friends who've already done it. And that would probably help a little bit. Okay, so we are now going to move on. Give me just a second to methods of collecting data. So now that we know what types of data there are, we need to figure out how we are going to collect these data. And so we are now on page 19. And the way they structured it is a little weird. So the first two, observational study and experiment, are on page 19, and the simulation and survey are on page 20. So let's go through each of these and talk about what types of data these are, or data collection methods these are. So in an observational study is a study in which a person observes and records without changing the conditions. I have to make this a little bit smaller. So yeah, hopefully you can still read that okay. So yeah, in an observational study, it's basically just observation, right? You cannot change anything. You cannot go in and switch up the variables. The only thing you can do is sit and watch. You can't force anything to happen. You can't change anything. You can't make anyone, you can't get another person to do something for you. You can only sit and watch. On the other hand, we have an experiment, which is a study in which treatment is applied on a part of the population and the response is recorded. And so in an experiment, you actually change something, right? You give what is called a treatment. And in this case, usually you would hear this more in terms of medical fields where treatment is referred to as medicine, right? In statistical study, treatment can be more than that. For example, if I'm conducting research about how fast a plant grows, right? The treatment can be the different types of fertilizer that I use. If I have a study about the effects of coffee, the treatment might be the different types of coffee that I use. And so it doesn't have to be medicine. Treatment is just the thing you are changing. Next up, a simulation. A simulation is a model, right? A study that uses mathematical, physical, or technological models to reproduce the conditions of the study. I'm gonna have to make this a little bit smaller again. Okay. So simulation is used when things are just too expensive or too dangerous to do. So for example, if I wanted to conduct research about the types of rockets that will survive in outer space, it would be very, very expensive to build several rockets to do an experiment, right? Um, it would be very expensive, and it might even be dangerous if I need to send a human up there too. And so in that case, we might use a simulation. We might build a smaller rocket and build a room that simulates the effects of outer space, right? Whether it's the pressure or the temperature. Um, we can even do it in computers now with technology, right? With technological simulations. And so uh, an example of a dangerous one might be if I wanted to see how a car accident might affect the driver of a human car, right? An experiment would one be dangerous and two be very unethical to put human bodies in cars that are guaranteed to crash, right? It would be very unethical. And so we would use a simulation instead, right? We might use a dummy human body, right? We don't use a real human body. We make a dummy that looks like a human, might even have some internal organs like humans, um, and then crash the car, right? Again, crashing the car might also be expensive. We might even have to use um, a computer simulation to do that. Okay, so that's a simulation. And finally, we have a survey. So a survey is used to investigate a study which investigates one or more characteristics of a population by asking questions. And very specifically by asking questions. So in this case, for observational study, experiment, and simulation, we are recording the results, right? We're recording what we are observing or what is happening. For a survey, we are collecting the responses from other people. Uh, instead of getting what we see, we are getting what other people feel or what other people know, right? And so it has to be very specifically by asking questions. Um, I'm not gonna stay on this too much, just because a survey uh, is something that you guys have probably done at least once before, and so yeah, I'll leave it there. Um, the important thing to know about this is which one to use given the situation. And so I do want you to flip to page 25. Page 25 have some examples that you can do to have your own understanding. I'm gonna do the first two, and I'll let you be able to do the rest, right? So number one, a study on drinking coffee and increase in metabolism. So I want to see, okay, if you drink coffee, does your metabolism increase? And so there are a few ways I can do this, right? Um, I can do a survey. I can go to people who are drinking coffee and ask them, hey, before and after drinking coffee, did you feel an increase in metabolism? And get responses that way. That is perfectly fine. I can also do an experiment where I get people to start drinking coffee and then see what changes. Um, can I do an observational study? Yes, but in an observational study, I cannot ask someone to start drinking coffee. And so whoever I choose to watch, I need to just sit there and wait until they start drinking coffee and then record the results. And so an observational study would probably not be the most efficient way to collect this data. Number two, a study of how high school students solve a logic puzzle. And so this might be a survey, right? I might ask, hey, how would you solve this logic puzzle? And they would answer my question, right? it can also be an experiment where I give different logic puzzles and see how different people solve it. It can also be an observational study, but that means that I need to wait until someone else naturally gives them a logic puzzle for me to be able to watch, right? As the researcher, we cannot give the logic puzzle because that would be a treatment. And so hopefully that explains things a little bit. Okay, and so we'll move on. So we are now at methods of selecting a sample. And so this is on the bottom of page 23, and it goes all the way to page 24. And I will definitely need to make this a little smaller. Okay, so it says 4 types of random sampling, and that's because I'm going to put an asterisk besides convenience, because that is the one type that is not very good. And I'll explain more later. So as I said before, a sample can either be good or bad, right? And a good sample is always random, or it at least has a random element to it. And hopefully the sample that is randomized will represent the population well. So let's start with the first method, a simple random sampling, or simple random sample. This is a sample in which all subjects have an equal chance of being selected. All subjects have an equal chance of being selected. So for example, if I have 6 people, I might roll a dice, right? I might just go, you're number 1, 2, 3, 4, 5, 6, and I'm gonna roll a dice. You all have an equal chance of being selected, and that's how I might do it. I might use a deck of cards, right? And say, okay, each card is one person. I'm gonna draw a random card, and that's who I'm gonna select. Or I'm gonna draw 10 cards, and those 10 are gonna be who I select, right? And so it's completely luck based. There's no categories. Every single person has an equal chance. The danger of this, of course, is that it might not represent the whole population, right? For example, in a study of Cricks, it could just be that all my randomized numbers are all seniors. It is completely random. I just randomly got every single senior and no one else. And so that's kind of the danger of simple random sampling. But if your research doesn't care too much about the different characteristics, then a simple random sample would probably work out okay. Next up is stratified. So this is on the next page. Stratified is a sample in which the population is divided into non-overlapping groups and groups called strata, and SRS is performed on each strata. I'm gonna make this a little smaller again. Hopefully you guys can still read that. So in a stratified, and I'm just gonna draw an example here and then erase it. So for example, again, I might do a research of Crick students, right? And I might go, okay, I'm gonna divide the whole student population into their grade levels, because the grade levels are non-overlapping, right? Every person is in one grade and one grade only. And then I'm gonna take 2 people from each grade, right? And so each strata, my strata will be grade levels. And then I take 10 people from each, or 10 is probably too much, like 3 people from each grade. And that would give me a pretty accurate representation of the Crick student population, right? I'm getting 3 people from each grade. That'll be 36 subjects, 36 students, and that might be a pretty good representation. So the important thing here is that the stratas, each strata is non-overlapping, and that they are different, right? You can't choose something that that there might be overlap. For example, nationality might be something that I can't really use, right? Because some people are citizens in 2 different countries. Um, Same problem lies with ethnicity or hair color, because there might be overlap in between 2 groups, right? And so yeah, so the groups need to be non-overlapping. And now we get to a slightly similar method of sampling. So a clustered sample is a sample in which the population is divided into similar groups called clusters. We then select all members in one or more, but not all, clusters. So the biggest difference between a cluster sample and a stratified sample, well, there's 2 main differences, is that in a clustered sample, all the groups are similar. So for example, in stratified, I gave the example of grade levels, right? First grade, second grade, third grade, fourth grade, and so on. A first grade group, the strata first grade, is not the same as the strata 12th grade, right? They are very different groups. In a cluster, we want each of these groups to be similar. So for example, I might do sports day teams, right? During sports day, the organizers try to make the teams as similar as possible, right? Have an equal-ish amount of each person in each grade. And so a sports day team might be a cluster, right? And then we select everyone in that cluster or everyone in some clusters. So I might choose to interview every single person in 3 different sports day teams. And that would be how I do my cluster sample. So yeah, that's the difference between a cluster and a stratified. Again, I'll do some examples in a little bit. Okay. Systematic is the non-random version that still works. So a sample in which the population is ordered in some way, and then selecting individuals at random intervals. Not random intervals, at fixed intervals. And so, for example, I might line up the students by height, every single student, and then choosing every third person, right? And so I'm getting 1, 2, 3. You're in my survey now. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and getting every third person. I might line them up by age, and again, every 5th person. I might line them up by student ID numbers and get every 4th person. And so systematic is the easiest one to identify, where I order the population and then I get every X person, right? Every nth person. And so that's systematic. Last one, convenience, is a sample that is easy to get. That is easy to get. And usually this will not be random. It might be a researcher just asks 10 of his best friends. It might be that a a teacher just chooses the first 5 people to walk into school as their sample. It might be that someone just asks for volunteers, right? All these are samples that can have bias. For example, the first 5 students to come to school probably have very different opinions than the last 5 people to come to school, right? And so, especially if it's something about, oh, do you think school starts too early? Well, the first 5 students that comes to school probably have different opinions than other people, right? And so, convenience sampling has a lot of biases involved, and it's not something that we should do. Okay, some examples are, I'm now on page 26. There's 7, 8, 9. Well, 7 is just the what is going on, so it's really just 8, 9, 10, and 11. So question 8, Mr. Swenson selects a class at random and surveys each student in that class. And so the assumption here is that in a single class, every single class is similar in terms of student distribution. And so here, number 8 is a cluster sample, because each class is a cluster and he surveys every single person in that class, right? Number 9, the student population at UF is divided into majors, and some students are randomly selected from each major to take a survey. And this is a stratified sample. The student population is divided into majors, and so every single person usually has one major, right? And then some students are randomly selected from each major. So we go to every single major and we get some of the students. The way I like to differentiate between stratified and cluster is that for stratified, I say that we are selecting some from every group, some people from every group, and for cluster, I'm selecting everybody from some groups. I'm gonna write that here. Some from every group. And then in clusters, we have everyone in some groups. Some people. And so that is probably the easiest way to kind of differentiate between the two. All right, last thing. This is the last thing in the lesson, which is biases. So you've probably heard of the term bias before. It usually just means that something is subjective, right? Biases in statistics means that it is something that might change the outcome of the research. These are things that might change the outcome of the research significantly. So there are 5 types of biases. 4 of them are on the top of page 27, so that's the first 4. And sampling error you can write right below it, but there is also space for it on page 20. But I'm okay with you just putting them all in that section on the top of page 27. So, response bias. A response bias is if, usually this is with a survey, but it can also be with experiments or observational studies. It is when a person is pressured to be untruthful or misleading in some way. Usually because of societal pressure. Okay. An example of this could be about cheating, right? If a teacher gives a non-anonymous, so this is not anonymous, and required survey that asks, did you think about cheating on your last test? Chances are there are probably some students that are going to be not truthful or misleading, right? Just because they don't want to be that person that says that, yeah, I did think about cheating. And so this would be considered a response bias in that um, there's pressure there to not be truthful, right? This can also be with experiments, like if a person acts a certain way because that is how society wants them to act. That would also be a response bias, right? You're recording a response, but that's not really what they want to do, right? A non response bias is when the people selected are unwilling or unable to uh, have their data collected. Again, this is mostly with surveys. If you've ever received an email that says, hey, can you please take this short survey to give us feedback? I'm going to assume that very few of us have answered those types of surveys. Um, but that is an example of non response bias, right? We don't want to answer those types of surveys. And so the company might have sent out thousands and thousands of surveys and maybe get 100 back, right? And that's non-response bias, is that the people that we want to get data of are they either don't want to or they cannot have their data collected. And so that would be non-response bias. Next one on the list is wording bias. So a wording bias is, and this is almost exclusively for surveys, it is when the wording of a survey is when you say favors one response over another or is loaded. So the first part, favors one response over another, might be something like, do you hate the rain because the humidity goes up? Well, because of that phrase, because the humidity goes up, it makes us want to say no, right? Because humidity makes things hotter and it's just not great in general. And so that one, that survey question wants us to answer, yes, I don't like the rain because humidity goes up. A loaded question is when it's asking two questions at once. For example, if I asked in a survey, do you like cats or dogs? Well, what if I like one and not the other, right? It's a question that has only a yes or no, and that makes it difficult to answer it truthfully, even if you want to. Okay. Um, two more. Voluntary response bias. Okay, so a voluntary response bias is the volunteers select themselves for us to participate. Now, the danger of this is that for a voluntary response bias, usually you will get people that feel extremely strongly about something. The biggest the biggest place you can see this is with reviews, actually. So either movie reviews or restaurant reviews or things like that. If you had an okay experience, it's not super great, it's not super bad, you are less inclined to leave a review, right? Like it's just okay. There's nothing else to say about it. But if you had an extremely good experience or an extremely bad experience, you are more likely to volunteer yourself to leave a review, right? Either this place is great, I had such a good experience, or this place was not great, right? Like everything was slow and things like that. And so voluntary response bias is when you ask for volunteers, and usually asking for volunteers gives you people in the extremes, right? Either they extremely like that something or extremely dislike that something. Finally, sampling error. When the sample does not represent the population well, or the sample is not a good fit for the research. So sampling error could be I just had a bad sample, right? Like I'm doing a survey of this Crick students and I got only the 12th grader even though I randomly selected it. That is a sampling error, right? Like I'm not getting the opinions of say 9th grade or 5th grade. And so it doesn't represent the Crick student population well. An example of the sample is not a good fit for the research might be if I'm doing a survey that is about sports, right? I'm doing a survey about sports and whether or not people enjoy sports, and I'm sending it to people that are subscribed to the magazine National Geographic. The sample there is probably not a great fit, right? If I'm studying about sports and I'm sending surveys to National Geographic readers, I'm probably not getting the information I want. And so that would be a sampling error. And so some example problems you can do is on page 28. I'm going to do the first one. 10 of the students that were randomly selected to take the study habit survey refused to take it. And so this will be non-response, right? That they don't want to do it or they can't do it. And so 10 of the students we just don't have data for. And so that would be non-response. And so the rest of the chapter 1 are usually just exercises that you can do. You can check your answers with me or with a peer. And I will also be uploading a worksheet to go along with this video that you can do to show your understanding. And that should be okay in terms of what you need to know for Unit 1. So if you have any questions about this, you can send me an email, let me know, or you can come talk to me during class. Yeah, just let me know if you have any questions.